Hi, we are PBS Consulting,
and we've had the opportunity to construct a feasibility report on the pedestrian access tube to span the Coronado Bridge. We received an RFP with specific instructions to design a tube fitting through the concrete pillars of the bridge. In the video ahead, we will brief you with our findings that we believe to have truth and accuracy. Hi, I'm Kyle Anderberg, Project Manager and Head of Structural Calculations. This pedestrian tube was designed to be fabricated and constructed quickly. With that in mind, standard and common steel members are used. A mixture of W and C-shaped beams are used to support the structure, while simple connections, including plates, bolts, and welds, were designed for easy connectability. Typical sections were designed in a 30-foot section and are to be repeated along most of the bridge. Like stated before, it was designed to be supported on a simple frame so that an aesthetic tube-like look could be created and would only be considered in calculations as a dead load. Due to a 200-foot minimum requirement for barges and naval ships, the pedestrian crossing must emerge from the concrete arches and sit flush with the steel girders for a period of time. This allows for the design of a viewing deck located towards the center of the bridge. A 100-foot truss structure was designed to support the typical section tube, along with a 20-foot extension as a viewing deck. This viewing deck will allow for the clearance, as well as a wonderful focal point to watch San Diego sunsets and the scenic downtown skyline.
Hi guys, I'm Devin Rattray, and I completed the transportation analysis. Now, on to transportation engineering. In order to conduct a traffic impact report on the Coronado Bridge, first, we must research the existing conditions. The 5-lane highway accommodates an average of 73,000 daily vehicles. The roadway is graded with a 4.7 slope in either direction. Next, we must consider the mobility features of the Coronado Bridge pedestrian tube. Our preferred alignment consists of approximately 11,300 feet of a tubular bridge paved with lightweight concrete. The shared use path will be accessible to both pedestrians and bicyclists. The typical section of the pathway will be 12 feet wide, with 2 bicycle lanes, each 3.5 feet wide, a pedestrian walkway, which is 4 feet wide, and a 1-foot buffer zone, to safely accommodate the variable speeds of traffic, all designed to meet both ADA and AASHTO standards required for this type of facility. Over the length of the span, the pedestrian bridge will elevate 200 feet to accommodate for Navy ships to pass underneath. To determine the trips forecast to be generated by the proposed Coronado Bridge pedestrian tube, SANDAG, MTA bus route, and City of Coronado data were utilized in accordance with the San Diego Forward Plan, as well as several similar projects and bike lane projections from other cities in the United States. Cities in the U.S. that have recently increased the number of bicycle-friendly facilities include Seattle, San Francisco, Portland, New York, and Washington, D.C. The usership that has been used to help determine the potential for bicycle commutes to cross the Coronado Bridge can be seen in Table A. Similar projection methods were used to create trip generations for other significant users like leisure bikers, runners, and tourists. In total, we estimate 1,819 daily users on average. These can be seen in detail in the traffic impact report. And finally, the proposed Coronado Bridge pedestrian tube will have significant impacts on the future of transportation in this region. By 2030, we forecast the tube to generate about 4,300 daily trips, reducing total vehicle miles traveled by over 5 million per year. This data can be seen in the table and graph included to your right. Together, the pedestrian tube design and its significant impact render the transportation project scope feasible.
Hi, I'm Jon Uriu, and I completed the environmental impact report.
The purpose of the project was to conduct a feasibility study on whether or not pedestrian access could be added to the existing Coronado Bridge. As the person taking the lead on the environmental aspects of the feasibility report, it was my job to conduct research to evaluate the initial conditions of the existing environment, as well as predict what impacts could arise from the building of the bridge. A sequence checklist was completed to identify the initial impacts that could arise from the pedestrian bridge. The checklist identified numerous areas for potential impacts, including air quality, transportation, land use, and biological habitats. After identifying the initial impacts, each was evaluated to see if the problem was critical. These were deemed red flag impacts that could potentially make the project infeasible. 2 impacts posed threats to the feasibility of the project. The first was Chicano Park. Early in the project, Chicano Park was chosen as a potential landing point for the pedestrian tube. It was an ideal location since it already had established infrastructure such as parking and a recreation area. It is also where the existing bridge drops down into the city as well. However, after conducting initial research, it was determined that Chicano Park is on the National Register for Historical Landmarks. This is due to the historic value of the murals that depict the Chicano civil rights movement. The second potential red flag issue was with the community acceptance of the bridge. After speaking to the current mayor of Coronado, it became clear that the city of Coronado was unwilling to help fund or support the project. If the community strongly opposes the bridge, then the project could become infeasible. At this stage, none of the initial impacts were determined to cause the project to become infeasible. Chicano Park as a landing point can be mitigated by searching for a second landing site. Also, there has been no formal complaints against the pedestrian tube. Therefore, the communities on either side of the bridge have yet to become a significant problem. If the project moves forward past the feasibility stage, then more impacts may be discovered upon further analysis and testing.
Hello, my name is Kevin Hoover, and I completed the construction report.
The construction of the pedestrian tube underneath the Coronado Bridge will be broken into 5 segments. Segment 1 is located on the San Diego side, where a landing zone will be constructed right next to the Barrio Logan trolley station. Segment 3 is where the observation deck will go due to the minimum height clearance of 200 feet. Segment 5 is the other landing zone, which will connect to the Coronado Island at the Bayshore Bikeway. Access to the Coronado Bridge will be easily maintained with the proper traffic signals to allow crews to gain access to the Coronado Bridge and be able to work from the east side. The construction process of a typical section of the pedestrian tube will be broken into 7 phases. Phase 1 is the connection of T-beams to the existing steel girders of the Coronado Bridge. Phase 2 is the connection of vertically C-shaped beams to the T-beams. Phase 3, you will need to weld steel plates to the C-shaped beams and then attach a horizontal beam between the 2 C-shaped beams hanging. Phase 4 is the attachment of 3 horizontal beams that stretch across the 30-foot section. Phase 5 will be the placement of prefabricated lightweight concrete to provide foundation for the bridge. Phase 6 is the attachment of fencing and handrails that provide the safety for pedestrians using the bridge. Phase 7 will be the construction of light fixtures, trash bins, and blue light call boxes. The estimated construction duration for this project is 540 days. It is determined that the observation deck will be the critical path. Crews will have to work from the side of the Coronado Bridge as well as from barge cranes on the water. Due to the high volume of traffic flow, most construction will take place during the night.
Hi, my name is Taylor Mishler, and I was in charge of the cost analysis as well as helping out with structural calcs.
The cost estimate shown here was strictly a capital estimate of the materials used by our specific cross-section. This estimate shows the basic cost of each member used by our structural design for the entire pedestrian tube to be included in the 2-mile span of the bridge as well as the center viewing deck. Each member of our design is broken down individually by the quantity needed for the entire bridge, the price of each member individually, as well as the total cost amount for each member for the entire tube. These unit price estimates were found by using the Steel Dynamics Incorporated price sheets as a relative guide. Being a feasibility project, our cost estimate is obviously subject to a wide range of variation because of the abstract nature of our design being a single option to be constructed and not being a final product. This cost estimate then goes on to establish a rough idea of costs for the construction, including labor and construction materials. The final cost estimate we at PBS Consulting came up with was slightly more than $21 million. We know this project would be considerably more expensive because of the vast amount of components not included in this estimate that we at PBS Consulting cannot obtain on our own for this feasibility project. Our goal with our cost estimate is to give an idea of how much the project would potentially cost in just materials. Overall, the general cost of the Coronado Pedestrian Tube could range anywhere from $75 to $180 million, depending on the design used for construction.
We here at PBS Consulting believe that a pedestrian access tube is completely feasible. Yes, there may be some difficult scenarios, but nothing clearly defines this project as infeasible.
We hope you enjoyed our presentation, and if you need a job done with passion and integrity,
Choose PBS Consulting.